going to try to talk from a kind of high level view at first and kind of funnel us down to some really on the ground specifics in Oregon to a part of the world that does form some of our broader research. And as the title implies, we're using a couple of case studies here, Intel and Meta. I'm sure you're all familiar with these companies, but just to say it, Intel principally a semiconductor and hardware manufacturer, Meta being a platform and thus dependent on semiconductors, but of course also the data center regime as well. Um, Okay, there we go. Okay, so because I know people may be in a rush, I wanted to start right away with sort of key takeaways, and then I'm going to get into things like how we did this work and some of the empirical details. So I would say the top level issue that we've found is that when you look at the various material from the companies that we've investigated, from an arithmetic or spreadsheet perspective, the numbers that they are conveying are true, but those numbers have little or no connection to real ecological relationships on the ground, as it were. That's a bit abstract. I will get into more specifics of that to show how that works. So the calculations that these companies use to calculate what they call net positive water are based on an accounting method. That accounting method goes by the acronym VWBA, or Volumetric Water Benefit Accounting. So that's a mouthful. So I'm just going to be sticking to the acronym there. Sort of the second top level finding I would try to suggest here is that this accounting method really sets up a mismatch between the mathematics that underlie the calculations and the real locations of where the companies operate, like where their actual facilities are, and where they're doing these projects that, if you take them at their word, are also doing water benefit to the actual landscape, for want of a better word. Those two top levels sort of lead to a result where essentially the way this accounting method, VWBA, is actually being used in corporate practice, it runs free of governance, whether that governance is about public bodies like states or municipal governments or whatnot, because their jurisdiction are typically tied to their jurisdictional boundaries or state boundaries, sometimes watersheds, not always. But it also runs free even of the best practices that VWBA says itself companies should use to do these calculations. So with Intel and Meta, when they actually put it in practice, they don't always adhere to what the accounting method said is best practice. I can get into that as we move along. Ultimately, the entities that are benefiting the most from this accounting method, not too surprisingly, are those who already have most of the power. The corporations like Intel and Meta that can burnish their sort of sustainability bona fides, and as well as the professionals who work to perform and report these calculations. Okay, those are key takeaways. Let me get into how we actually did this work, or sorry, some of the history behind it, and then the method. So, as I say, volumetric water-based accounting is an accounting method made up by other people. It was initiated in 2017 through a consortium organized by the World Resources Institute, involving all of these different companies that you see on the screen there. Intel and Meta were the two tech companies that were part of this group sort of from the beginning. They provided funding and organizational support and whatnot. Since volumetric water-based accounting has been developed by this group, other tech companies, Apple, followed by Amazon, Google, Microsoft have come on board and are now listed as funders and participants in this working group. And although those newer tech sector entrants, to my knowledge, they have Apple, Amazon, Google, Microsoft have not yet reported water metrics that refer specifically to VWBA, but they're clearly on board. So what Intel and Facebook, in a sense, got started for the tech sector is coming for the broader tech sector. This is way too complicated to go through in any sort of detail. I just wanted to demonstrate how this working group set up a whole series of indicators that companies could use to measure this different ways of achieving water benefits. So if we start in the top left-hand corner there, there's one category called land conservation and restoration. Essentially, the accounting method says you can do anything that allows your company to avoid runoff or to reduce runoff from a site where your facility operates. That counts as a benefit. And if you go across the row there into Appendix A1, you'll find the mathematical formula that's recommended to be used. So I'm just pointing out there's a VWBA is not a single thing. It's many, many different things that companies can use to measure their water benefit. What all of that complexity boils down to are things like this, just straight out of a relatively recent Intel sustainability report, where there's a direct reference to net positive water, you see at the top. And when you dig into the footnotes of these reports, you will find references to volumetric water-based accounting, or VWBA, which traces back to that World Resources Institute consortium. At a very basic level, net positive water is just measuring how much water goes in versus how much water goes out of a company's operations. And what companies are trying to do is balance that out. And indeed, if they can do some sort of practice on the ground that they claim is a extra benefit of water, then they can actually, they claim, go net positive. So in other words, here Intel is claiming, sort of down towards the bottom left, that their operations use 13.5 billion gallons per year. And on the opposite side of the equation, water out, they claim 13.1 billion gallons are returned back to the system. Plus, because of some stuff Intel does, like water restoration projects in streams here and there, they claim they are adding another 2.3 billion gallons per year to the system. So they've gone into surplus. It's net positive. That's the claim. So Mel and I wanted to really dig into how these numbers are built, what are the premises they're built on, and then what do they actually mean in practice. And so we used a couple of methods to do that. On the top of the screen, I'm trying to visualize what we called citation tracing. And on the bottom of the screen, some basic spatial data analysis. To talk about citation tracing, Mel and I just collected the documents that were being published by the World Resources Consortium in the center there, the sort of yellow with the red dash around it, and their discussion of VWBA. And we just traced the citations in those reports backwards to where we started landing on the actual discussion by hydrologists and geomorphologists, in other words, domain experts, and the hydrologic models that were being used. There's a very complicated acronym there, PCR GLOBWB2. That is what scientists refer to as that is a specific hydrological model that they use. So once we found that in the citations we were tracing, we were no longer finding references to volumetric water-based analysis, we were finding references to a specific model. When we trace the citations in the opposite direction toward Intel and Meta's reports, we bumped into this thing they were calling net positive water. So we were just linking all of that up and trying to see how these numbers that they're reporting, what are they premised on? How are they built? And what does all of that mean? To that, a second method was just to do some very basic spatial data and sort of basic quantitative analysis where companies report where the locations of their facilities are. They are also reporting the location of where they say they're doing these water restoration projects. And we just lined those up, as it were, on a map. And as the little cartoon suggests there is not always a good matchup between where the facilities are, depicted as little red triangles, where the water restoration projects are, the little blue circles, and where the actual watersheds are, that sort of green splotch. And so, again, to go back to the top level finding, arithmetically, what's being reported is mathematically correct. But ecologically, there can be a gap, oftentimes a big gap between what is being reported as a number and what it actually means from an ecological point of view. Okay. All right. We also did a little bit of strategic quantification where we basically took the sustainability reports from Intel and Meta, where they usually in a table form are reporting their water use and benefits. Tables are fine so far as they go, but when you graph the numbers, patterns emerge that aren't always evident when it's just rows and columns of numbers. So this is a little bit complicated, but I just want to emphasize that the solid lines that you see here, the dark blue, the light blue, the dark green, and the yellow, those represent numbers actually being reported by Intel in its sustainability reports. And these are megaliters of water and the year across the bottom. So the dark blue is what Intel claims is its total water withdrawals. You see it starts around 60,000 megaliters and seems to take a big steep drop and then kind of flatten out. The light blue is what Intel is claiming they are returning back to the systems that they operate in. And then the dark green is their measure, Intel's measure of the water they are restoring to the systems they operate in. And the yellow is what Intel says they've consumed. In other words, the water lost that they can't recover back to the system. The solid lines are their actual reported numbers. We just did some basic a linear regression and say, okay, we're going to take Intel at their word. If the trends that their numbers show hold into the future, what does that look like? And we see that, not too surprisingly, we pretty quickly get into a big gap between the amount of water used by Intel and what is, as it were, fed back into the system. Digging into these numbers even a little bit further through either public reporting in like industry news, we find that I don't know if people can see my mouse moving around. Can people see my mouse moving? All right. So this steep decline, you might think out of context, oh, gee, wow, Intel's getting way better at water use. But actually that drop results from Intel selling a single facility in Dalian, China to a separate company. And as a consequence, the water use by Intel goes way down. Now, of course, that water use doesn't go away. It's just being used by that other company, right? But from looking at that from Intel's point of view, it seems like a steep drop. If we go down here, we do indeed see the company by its own numbers going net positive, albeit briefly. The numbers they report are always a few years, a year or so behind. So when we did this work, only up to 2024 were available. very quickly, if these trends continue without any change, then the company will no longer be net positive. Okay. It gets, I was going to say murkier, more complicated. It's not really that. It's more how do these numbers, what do these numbers mean when you change the scale at which you look at them? So Intel reports its water surpluses and its water deficits at a country level. And it very explicitly in its reports balances those differences by taking surpluses, say in India, and marking them against their deficits in, say, China. When you do that, mathematically, you can come to a surplus. But of course, as it were, surplus water in India has little or no ecological meaning for people, places, biologies, ecologies in China or any of the other countries that you see painted orange in this diagram or this map. So you can also maybe see, so the purple squares are where Intel's actual facilities are. Most of their water restoration projects, represented by those dark blue circles, are happening mostly in the United States. So again, surpluses, as it were, built up in a region like the United States have no ecological meaning for deficits in regions like China or Indonesia or what have you. Okay, same thing. We're switching companies, except so we're with Meta now. Again, the solid lines are what they are actually reporting, dark blue being total, what they claim is their total water withdrawals, the black being what they claim is their data center totals. So they've split out total operational use, like everything from offices and data centers, et cetera, et cetera. They've also split out data centers separately. And then the dark green is what they claim is their total water restoration based on projects that they are doing on the ground. When you project their own reported trends forward, you see a sort of similar little period of time of 5 or 6 years that if their numbers, if we take them at face value, they will indeed be net positive. But if those trends continue based on their own data, very quickly Meta will be no longer net positive and will be back into extracting more water than they're putting back into the system. Um, the I didn't say anything about this lighter green line. It's a little bit more complicated in that Meta started reporting water restoration that it would be doing in the future back in reports that were being published. So in other words, it's sort of claiming we are going to do these things, and so the future is all the brighter. So, but even when you include those, again, based on their own numbers, the net positive drops off fairly quickly if those trends continue. Again, an example of the how these methods work out. They're true mathematically, but from an ecological perspective, don't hold a lot of meaning. So this is a mapping Meta's data centers in the United States, shown by the little red triangles, versus where they say their actual water restoration projects are, the little blue circles. And the big green splotch kind of in the middle there is the Mississippi River basin. The black lines within it are just the sub basins of the Mississippi River. Hopefully, what you can see is that all of these facilities that I'm pointing at here, the data centers, they have no water restoration projects associated with them, except this one project over here that, if you zoom in, is kind of like on the border of New Mexico and Colorado. So again, the math is correct, but the math has little or no ecological meaning. All right, let me zoom in because this is pretty abstract. Let me zoom in on a real place, Prineville. This is a something we do in the paper that this is part of. To give you a sense who don't know Prineville, it's in Crook County, Oregon. I'm also conscious there may be people from there on the call who know a lot better than I do. But anyway, for those who don't know, just to give you a very high level view, Prineville, in the top right corner there is a satellite image of Prineville. You'll notice a sort of large brown patches with smaller green areas. This is an area that, among other things, has irrigated agriculture. Those are the green patches, but is otherwise pretty dry, which you get a little bit of a sense of in the bottom left-hand corner, showing an image of more or less the center of Prineville. And Prineville, like a lot of places, has been keen to attract companies like Meta and Intel, and which this news item in the bottom right-hand corner tries to give a sense of from way back in August 2010, when Facebook was looking for a place for a new data center, and they located in Prineville in part because of tax breaks that were being offered, a 15-year tax holiday. So they only started paying taxes, if this is accurate, last year after opening there in 2011. This map shows what Meta is actually doing in Prineville as a water benefit project. They are they have built extraction wells on the Crooked River here, and in the wintertime, they pull water out of the Crooked River and it's pumped upstream into recharge wells that as wells they're underground, which then seep slowly underground to be used by water users in Prineville and the broader region. This is I don't want to suggest there's anything wrong with this. This is the kind of thing towns and places do all the time in order to time shift ecological characteristics of a place, so that there's things like enough drinking water through a hot, dry summer. You build a dam, you collect the snow melt, and behind the dam is a reservoir that you can siphon off more slowly over the summer. So I'm not suggesting there's anything wrong with what's happening here. But I do want to start getting into how the real nitty-gritties of these water benefit projects and the numbers that are reported, thinking about the difference between those nitty-gritties and the numbers reported are really important, because in Prineville, and I know this is a complicated slide, so let me go through it. As everywhere, though differently, experiencing the climate emergency, Prineville is in a region that is increasingly experiencing drought. So across the top is this brightly colored yellow and in yellows and reds is U.S. Drought Monitor data for Crook County, Oregon, for over basically the last 26 years. And so along the bottom axis here is time. So we start in 2000. We're now at 2026. And along the horizontal axis, this is the percent of the county, the areal percent of the county that is experiencing drought. And so, and the colors, the deeper red, not too surprisingly, the more severe the drought. So if I just go to this region here, we can see for this period of time between 2001 and 2002, 100% of the county was in some stage of drought, everything from abnormally dry all the way up to the extreme drought. If we move forward in time, 2010 is when construction on the Meta data center at Prineville begins. It opens in 2011, so it's now operational. And then if we follow through in time, we see that drought has been experienced if not constantly, nearly so in this county. And especially from 2020 through 2020, sorry, through the end of 2024, 100% of the county was in some form of drought, including the highest category, exceptional drought. When I made this chart, the latest data were not available. So this is from yesterday. It's added just a little bit of data. So we're now into the sort of mid 2026. And it's showing us that at least 60% of Crook County is in extreme drought. And we still have August, September, October, November, and it's really not until, December, January, even later when the real winter precipitation starts. So I wouldn't be shocked to come back to these data and find that the rest of the drought severity has increased substantially. The point being is that that water benefit project of pumping the water uphill, it's a legitimate practice, but it has limits, right? As the region moves more and more into an increasingly dry climate regime, those kinds of, as it were, local water benefit practices are going to, if they aren't already, will eventually bump up against the limits that they can do in terms of providing a water benefit to the local situation. So that is it. This is just the key takeaways that I started with. I hope I've offered a good high level view with some decent specifics here. I think mostly what Mel and I are interested in are your questions and discussion and what follows from this. So thanks very much, and looking very forward to your questions and responses. Thank you.
Thank you so much, Josh. That was really amazing and a little bit shocking. I mean, not surprising, but
Oops.
upsetting. No need to oops. It's all good. At this point, I want to invite people to write your questions in the chat. Thank you very much. We've got one getting started, and I'll read it aloud in a sec, but everybody else should also dig in. Before we go to questions, I'm going to turn the spotlight on to Professor Mel Gregg from the University of Bristol, who's going to just talk a little bit more about this research that they've done together. So thanks, Mel.
Thanks, Judith. Yes, while you all get your questions together, I just wanted to give a little bit of context for this project because you may have seen or heard in the introduction, I'm a former Intel employee and actually lived in Oregon for basically the last 11 years. I moved to the UK to take up a job that would allow me to keep working on sustainability. So that's why I'm at the University of Bristol. But this project really began at Intel because I asked Josh to come in as a consultant while I was running a sustainability program there. And we were talking about different issues at that time. But we've kept the conversation going for many years now. And I was kind of curious when I started dipping my toe in sustainability work in the company, what do people mean? They keep talking about this term, net positive water, and I just couldn't get my head around it because I was living right next to the fab. I was looking at the watershed and I was looking at the land being cleared and I was looking at the activism for more land to be cleared. And I just couldn't reconcile these conflicting tensions. So it's just been in the back of my mind. And having also worked now for some time as a consultant at Meta, I was starting to see the language become more and more persistent in terms of the defense strategy. As water has become more scrutinized with the AI boom and the data center build out, it is really important, I think, that we know what we're talking about and that we understand the language that's being deployed in defense of these companies. And as Josh, I think, has said really clearly, there's a lot of excellent work happening in sustainability in these companies. What bothers me is that the commitments that are made, including commitments that my own CEO made when I was working in sustainability, can be torn up as soon as the change in leadership happens, or somebody gets a different sustainability job at a different company. And when you're in that profession, you're all using this similar language to create a consensus on what counts. And I thought it was really important for this community to hear about this particular example of how language can be used to obfuscate, but also to claim credit when it really does seem to be a strategy to deviate attention from the primary problem, which is we only have one planet. And if we continue to do sustainability accounting at company level and not at a more effective level of governance, regionally and internationally, we are not really solving the big problem. So this is one example. We also have some more historical work that we're doing on Oregon and particularly the Silicon Forest as an idea. I know you already had an event about that recently, but part of the reason we're doing that is to say that these are sacrifice zones that have accumulated wounds over many decades now. And so to only focus on data centers now is also to forget and to have a form of amnesia about what's already happened to the lands where these companies currently operate. So that's just a bit of context in case it's helpful. Thanks, Judith.
Thank you so much. That is incredibly helpful. And, I think part of our goal is not to have amnesia about this, and to, widen our capacity to appreciate the impacts across time and across space of these companies. So thank you for that. I'm going to now want to invite questions from the audience, and I will read questions aloud for our speakers. And if you could also make a comment if you don't have a question, that is totally legit too, because we've got 20 minutes. So I'm just going to run through the questions in the order that we've gotten them. Elaine Stewart, who I know is on the advisory board of Clean Water Services in Oregon, asks, and Clean Water Services is a publicly owned treatment works that handles Intel's wastewater, asks, in Prineville, what is the time lag between pumping out of the Crooked River and when water recharge happens in groundwater and is available to agriculture? It's a great question, Elaine.
That is a really good question. I don't know off the top of my head. Though I believe it is reported in the report that I pulled that map from showing the pumping. So I'd have to go back into it, but that is a publicly available document. Feel free to message me, and I'm happy to share it or point you in the right direction. So I don't want to speculate. Really, all I can remember off the top of my head about the timing there is that the water is extracted from the river during winter when agriculture demand is at its lowest, of course, because it's not the growing season. That's about all I can remember about the timing there but that doesn't tell you how long does that seep back. Yeah.
Great, thanks. Second question from Lauren Bridges is, are you considering scope 2 water used in power generation in your modeling?
So the short answer is no, and slightly longer is, and apologies if this wasn't clear, we're not doing any modeling. We have simply taken the numbers that are being reported. I suppose maybe we're doing modeling in the sense of taking those numbers and doing a regression line, but we're not doing any hydrologic modeling ourselves. We're just starting with what the companies say they're doing and saying, okay, let's take them at face value and see what their numbers tell us. So it's a kind of a kind of naive, deliberately naive, take them at face value and see what they say. And oh, it turns out that when you take them at first face value and see what they say, it's not actually a super great picture anyway, before we even get into whether these numbers are accurate underreported, overreport, all that kind of stuff. Yeah.
But I think that also the part of the point of the question is there's all sorts of hidden water use in the supply chain of
Oh,
these companies.
totally. Yes, totally. And I will say there, yeah, I don't think Intel and Meta split out scope one, scope two. They do for emissions, but there may be other companies that do split out scope one, scope two style water use. I saw a question coming up. I guess it's about TSMC. TSMC might be one of them. So anyway, yeah.
Do you want to take that question on TSMC, which is whether these metrics have been used by TSMC and other companies not on the World Resource Institute working group list?
Yes, so TSMC definitely. For those who want to look into it, I did a little blog post about this topic in the early days before we had finished this analysis and used TSMC's reports as one of the case studies. And so if you're interested in TSMC specifically, I you can follow that link I just dropped in the chat. Unless they've changed their practices very recently, then any current TSMC sustainability report should refer to net positive water. Yeah.
Great. There's another question that from Tamala Trussell, who's obviously concerned about a local data center, and I'm not sure that I can even read it accurately because it's kind of detailed, but so apologies in advance. But
Okay.
she hears that the evaporative cooling system for a 1 gigawatt data center uses 5 million gallons a day. What
Yeah.
water does that include? Local draw, water for energy, et cetera.
Yeah.
Is there a resource that could inform a community surrounding this evaporative coolant system that would tell
Yeah.
them how much municipal water the data center will likely use? They've only asked for 400,000 million
Mhm.
gallons a day. So what does that mean? Like, how can a community
Yeah.
know that or figure that out?
Yeah. So I cannot answer that one specifically, but I certainly don't want to overpromise here. So I would just say I would really encourage people to look really carefully at how consumption is being defined because even when Intel, like they might use the word we consumed X amount of water, but in which sounds like they, extracted a bunch of water, used it up, and it's gone. But it's not really. Some of it is returned to a local hydrologic system. It may be returned polluted and both toxicologically, temperature, all that kind of stuff. But physically, the water is returned to the local hydrologic system from what it was taken from. But also, some amount is lost to evapotranspiration, and once it's in the atmosphere, can be transported out of the local hydrologic system. So that word consumed, it's doing a lot of heavy lifting. And I would just encourage people to look really carefully at what it means locally in that specific, for that specific facility and that specific company. Consumed really might mean it's being evapotranspirated out of the system and is lost. Consumption might also mean it moves through the data center and then goes back into the municipal system. Again, polluted temperature, at higher temperatures, so on and so forth. But I'm sorry I can't offer something more specific than that.
I'm going to see Tamala put her hand up, and I am not sure if I can allow you to unmute, but why don't you try and see if you can unmute now and
Okay.
ask your question?
Yes, thank you so much. I just want to clarify. It's they're not the 400,000 gallons per day that they're talking about is how much they've asked from the municipality to draw. So
Okay,
so not consumption. And
right.
and they have many caveats in a lot of records of right to know, I'd say probably 10 or 12 of them, where they're saying with rights to ask for more water, more
Hmm.
storage, they are putting up enough storage for 10 million gallons. And there's three municipalities, the wells that are going to supply the water for Middlesex allotment. So like Middlesex has X amount of gallons, right? And they are allotting 400,000 a day to the data center. But that's just insane because they're an evaporative cooling system at 1.8 gigawatt. So where can I find information on what an evaporative cooling system that's 1.8 gigawatt or even smaller? And I can, do the math to make it total one, because I hear the numbers 5 million gallons for an evaporative system at 1 gigawatt. Where is that coming from? Is that including your scope, just your local
Yeah,
draw or the energy, water use for energy, et cetera, et cetera? Like, and including fracking to get the energy, because that's what I'm getting pushed back. I'm getting pushed back by the local leaders and Penn State Extension and a bunch of people that 5 million is including extraction of the gas, the,
mm,
making the electricity, and they're only needing a little bit from our local watershed. And
right.
so
Great. That's a great question. Josh, can you answer that?
Yeah, I mean, I doubt I can tell you anything you don't already know, because I just kind of default to getting access to local planning and zoning decisions and these kinds of things, which differs. Sorry, with the accessibility of which differs so much from jurisdiction to jurisdiction. I think I would also say that the my understanding of water use in these kinds of industrial systems, I mean, you might hear something like, the average data center or a 1 gigawatt data center on average uses X amount of water. But I just don't, I'm not an expert here, but everything I read about how those systems actually work, the idea of a universal metric of like there is an average data center and there's a direct and sort of linear correlation between as gigawatt increases, water consumption increases. I mean, broadly speaking, yes, it does. Use increases, but the different cooling systems involved and all of that kind of stuff makes so
It
much different to
opens
the
another
local.
can of worms on what language is being used because
Yeah.
the utilization of energy for cooling versus powering is another way that companies will flag that they are improving their sustainability credentials with each new build. And I think part of what is challenging with the AI hype is that everything is being called a data center, but we're really not comparing apples to apples
Mhm.
when we're talking about an AI hyperscale data center versus just your average data center versus like the multi-tenanted ones. It's also another point of clarification that even in the mapping that we've done, it's not really sharing the complexity of how much large companies in the cloud business right now are using leased facilities as
Hmm.
opposed to
Yep.
facilities that they actually own.
Hmm.
And anyone who's following this will know that there's a lot of money being made by companies that are creating the shell to then create
Hmm.
these multi-tenanted facilities. And that's another way of obfuscating the
Hmm.
responsibility for, who's really supposed to be accounting for that power use.
Yeah.
Um, and I think that's some area to watch too, as the technology inside the factories and the data centers improves. Um, the technology of building them is also being innovated on. So temporary structures are also very common right now in some of the companies that I've been consulting to, which means that you don't even have a building, you have a tent. So if you have a tent, what's the planning regulation for power supply for something
Mhm.
that's designed to be temporary to keep pace with the rate of innovation that's happening? And more complexities.
This is so great. We're running out of time. We've got about 7 minutes left, and I want to combine a couple of comments and questions. Um, Elaine Stewart says even if there's a net benefit for recharging the water in Eastern Oregon, it doesn't account for the project being located in a completely different watershed from the extraction. Dennis O'Mara similarly says, who's in New Mexico, that if if a company is contributing to the surrounding community by undertaking a sustainability water project, shouldn't we? It's it's a far cry between that and using that to try to minimize the negative impact of their operation on the available water in the vicinity of a plant. And then I think that Selena Barron sort of pulls this together by saying, would an improved way of measuring this be only counting water recharge or rehabilitation if it's in the same watershed, if it's where it's actually needed? Is that the main flaw that you've identified in the model, that it allows for water outside of a watershed to be counted as when you're accounting for the water use?
Yeah, I mean, sorry, I'm jumping in. Did you want to
Yeah,
go,
no,
Mel?
that's it.
Okay. I will quickly jump in and then see if Mel wants to add anything. I mean, I, I think if I could boil it down to like, there's no silver bullet here, but like the one weird trick, the one weird accounting trick would be to, yes, to have the water benefit project be directly linked in an ecologically meaningful sense to the facility that is using the water. And that's a key point of one of the takeaways is that in even though the accounting guidelines for volumetric benefit water accounting say essentially that you should do these projects where the facility is operational. That's best practice. The companies, in this case, Intel and Meta, use that arithmetic, but then we'll do things like counting a surplus in India to negate a deficit in China, which is, I mean, it's on the same planet, but but it has no ecological meaning at that scale, right? Yeah.
I mean, this is what folks who work on climate change demand in terms of greenhouse gas reporting, that
Mhm.
if you're going to try to offset your energy use by creating renewables, you have to do it in the same time frame and in the same area, the same part of the
Mhm.
grid as the energy
Yeah.
that you're using. Otherwise, it doesn't make any sense.
Yeah.
Callie Rabinovitz asks, can you talk about the hydraulic model that you traced the VWBA back to?
Sure. So we go into it in some depth in the actual paper, which I'm happy to share. It is it is a hydrologic model developed by hydrologists. Actually, I do have a slide. Let me quickly shift there. Oh, I suppose I have to share my screen. One moment. Um, Here we go. Is that big enough to see or not really? Maybe
Pretty good. It'd be better if you went to the presentation
let's
mode.
do that. How's that?
Great.
Okay, so the image with the irrigation, livestock, industrial, domestic, this is not something we created. It's directly from one of the volumetric water benefit accounting documents, diagramming that specific hydrologic model, the PCR Globe 2 model. Basically, it takes five different submodels, one for irrigation and water use, one for meteorological factors, one for land surface processes, one for groundwater, one for surface water, and so forth. And it divides up the surface of the Earth into these three-dimensional cubes and calculates water throughput in that little chunk of space. So it's taking the real world, pixelizing it into three-dimensional chunks, and using mathematics to model the flow of water through those containers. Um, and as we point out, this is a quote from our paper in the white box there. Um, the We're quoting a document from the Alliance for Water Stewardship, which is one of the bodies involved in this working group that is putting together volumetric water-based accounting. And they say, quote, a least desirable approach is one which relies on preset watersheds or river basin boundaries, et cetera, et cetera. But one of the things that we point out is that that is exactly what the hydrologic model PCR Glob 2 does. That doesn't make the model bad, as I'm sure many have all heard that phrase that, all models are wrong, but some of them are useful, or sometimes they're useful. That's what models do. So pointing this out is not a criticism of modeling, but part of what we're trying to point out in the paper is that as we down in the sort of left-hand corner here, when hydrologists and geomorphologists are talking about models like PCR, they are talking about it with all of the caveats, the sort of scientific caveats that come with scientific practice. But by the time you get to an Intel or Meta sustainability report, all of that scientific nuance, which may be highly quantitative, has been, if you will, airbrushed away and boiled down to a single number of we're positive or we're negative, right? Which has its own uses, right? I mean, a decision maker in Hillsborough versus I don't know, Mel, where's another Intel? um,
Close to me in Ireland.
in Ireland, at the end of fiscal year, when the accountants need to produce that sustainability report, the sustainability accountant in Ireland and the sustainability accountant in Hillsborough need to be able to talk to each other, and that number for water surplus or deficit makes them able to communicate. But it, of course, erases all, so, and mathematically it's correct, but it erases all of the ecological nuance and all of the technical caveats that would be going on when anyone is discussing, hydrologists or geomorphologists are discussing modeling. I hope that makes sense. Oops.
Sorry, I was just having trouble unmuting myself on classic Zoom error. Thank you so much. Our hour is up and it has flown by, and there are more questions and comments in the chat than we have time to address. We will have more of these brown bag presentations, and this one will be available, a recording, just missing the first few minutes because I forgot to press record when you started, Josh. Sorry about that. But this has been awesome. I have learned a lot, and I know that folks in the audience did. Thank you very much for being here, everybody. Thanks for being part of our community. I've put the contact information and website info for Professor Gregg and Professor Lepawsky into the chat. So reach out if you have more questions. Thank you all so much, and stay in touch.
Thanks very much.
Thanks, everyone.
Bye,
Thanks,
everybody.
Judith.